Hey everyone, today I want to test some appliance parts, but I don't want to test them on a appliance. So we're going to build a test cord today to hook up and test this drain pump for a washer and this garage heater kit for a refrigerator. I want to do this by building a system that will connect these spades to run the appliance without being on it. So what we're going to do is take this piece called a cheater cord and put some connectors on it and build one real quick. So let's do this and have some real quick fun today. This is a cord that I bought off Amazon. It's just a basic 2-prong, really generic and kind of crappy. I bought it because it has an on-off. I spent about $12 on Amazon to buy 4 of these, so I have multiple that I can put multiple connectors on. So the first thing we're going to do is we are going to go ahead and splice this together by just using a crimp connector and some spades and get this started. First thing I'm going to do is twist the wires, make sure that they're tight and secure. Then I am going to take my spade terminal. It's just a basic 14 AWG female. We're going to fit it on. I'm going to use the blue connector on my crimper. Now, if you're anything like me, you may want to get some time in learning to crimp better when you're working on a test cord. I goofed up on one of these during the filming, and one thing also I'm going to be bringing into the video next is a kilowatt meter to test the power draws on the 2 appliances we are going to test in just a moment. Now for the moment of truth. We got the on-off switch here, the kilowatt meter, which will allow us to see exactly how many watts this drain pump uses, as well as of course, the spade connectors. And we're going to try a few configurations and see what we can figure out to make it run right. I believe that on this, the live is going to be the blue and the neutral is going to be the brown. On a drain pump like this, I would imagine that if it goes one way versus the other, it's going to change the polarity and change the rotation of the drain pump. So let's see what happens here. And then we'll see if this works. Yep. Look at that. Drain pump is running, and we are at 10 watts. Just 10 watts of electricity to run this drain pump. What does it show? Oh, it doesn't sound the best either. 120 volts at 6 amps. So let's see this real quick. We're running 121 volts, and the amperage again is 0.6. So let's see. And it's running 5.3, so a little bit below, but it is exactly or almost exactly what it's supposed to. And the reason that we'd want to test this is to see if it's going to rotate with the wattage on it. One thing I'm going to do real quick is take my screwdrivers. Don't try this at home. I may kill myself, but it's still running okay, even though I put an obstruction in it. And the concern about a drain pump here is if a foreign object came in, it would stop the drain pump and possibly strip it out. But you saw the drain pump kind of repel the pliers that I had, so this drain pump is unquestionably good. Awesome. I got this right here, and we're going to hook our terminals up to the wires on this. You could splice in male connectors on this end so you could plug them in straight here, but since they have like a piggyback connector, we can change it out and just plug them in on the back real quick. So we have our hodgepodge here of wires, and then we have our heater. We're going to turn this on and see what happens with this test. Oh, there we go. We're at 13.4 to 13.5 watts. And I can feel a little bit of heat. I'm going to let this run and let's go grab something off camera real quick. About 99 degrees, somewhere between 95 and 90 degrees. And then the table beside it is only 70. So there's a 30-degree variance here. And now we know that this works really well. And you can feel the heat coming off of it, so that's really good. And I'm really happy with how this test cord turned out. All I needed was purchasing the cord, the splicers here, which I will include a link to. These are really, really good splicers. I had some others that I tried to put on a test cord and it utterly failed. and I was very, very disappointed. I got this one spliced really, really fast within about 30 seconds, but this one I've had trouble on, and it's because these crimp connectors I bought also from Amazon were total junk. So make sure you buy high quality crimped connectors, otherwise you're going to lose a lot of money. So these are the ones I bought, and I'm really happy with them. We're going to go ahead and shut this off. The wattage should go down to 0, and we are now safe to unplug and test some more stuff. But I hope that this idea for a test cord is a good one for you. Again, I bought a 4-pack of them so I could make some male connectors if I had better crimp connectors, and we could have a variety of cords with the on-offs on them for all kinds of appliance testing. And I hope this video helps you out, guys. Have a great day.